Hello guys, welcome back to my YouTube channel. So today we are going to continue our playlist Data Science Basic Interview Questions, which we have started. We have completed three questions. The previous question was explain linear regression, which we have completed. Now we are going to see the another question which is related to linear regression only. So I will be requesting you, if you have not seen my previous video, so go check out that video and then come to this video so that you can easily understand both the videos, like both the questions, and which was the basic explain linear regression. Now we will be seeing the assumptions which are there while building the linear regression model. So let's start the video. So in assumption of linear regression, there are six assumptions which are there that need to be taken care of while building the linear regression model. So we will be seeing one by one each of them, and I will be explaining you in detail. So let's start. So first is our in assumption of linearity, you have to check whether your y variable is having linear relation or not with the x variables. So suppose these data points are from the y variable, and here on the y-axis there is x variable, and if you are plotting your y variable data point, it should follow a positive trend or negative trend. If they are not having a linear trend, then uh, you can't go with the linear regression model. You have to altogetherly go with the another regressor model, like decision tree regressor or some other regressor, but you can't go with a linear regression model. And how you can check whether your y variables are having linear trend or not with respect to your x, means you with respect to your independent variable, that you can see with the scatter plot. And what if if the linear relationship is not seen in independent or dependent variable, then what you can do, you can just altogetherly change the model only, because it is not showing the linear trend on the y while you are plotting it on the graph with the respect. When you are plotting it, y variables data points are not showing linear trend. So you have to go with the another model, not with linear regression model. So this was the first assumption, which was related to linearity. This I have written about the graph, like this is showing positive linear relationship. Here negative, and here no relationship. If no relationship is there, then you can't go with the linear regression model. Now let's go to the second assumption, which is normality. Your x, in assumption of normality, the x and y variables should be normally distributed. Here, as we can see, your x axis, it is our x variables and x variable values, and it should be normally distributed. It should be bell shaped. When the we are plotting our x variable value, so it should form a bell shape when we are plotting it. So each and every x variable should be normally distributed. That is what it is written over here. And also the y variables should be normally distributed. If both x and y are normally distributed means the when we are plotting the x variables value and y variable value, it should be forming this type of bell-shaped curve. That what it is called as normally distributed. And how you can check this uh, by plotting histogram, KDE plots, and QQ plots, you can check the normality of assumption. So next, you there is homoscedasticity. This term is I will be explaining you by after you have suppose you have built a linear regression line, and you can see suppose this black is your linear regression line, and but the actual data points were over here. This black dots are there, that your actual data points, and it is having error that is called as residual or error. So as you can but you are able to see that your errors are going are increasing from left hand side to the right hand side. So if this pattern is seen after you build a linear regression model, then it will not give you a accurate result. And if after building the linear regression model, if you are able to see this type of pattern, like the errors are increasing, then it start to decrease. So this is also not it will not give an accurate result. So your error terms should be constant over the period of time, like this. Here you can see the error terms are same from the start till the end. If it is like that, you can get an accurate result with the linear regression model. That is what it is written over here, like homoscedasticity. Homoscedasticity can be checked by plotting a residual plot. Then the next is the fourth assumption is independence or no multicollinearity. No multicollinearity, I will be explaining, I will be just reading this and then I will be explaining. The variables should be independent of each other. Suppose in the you are going to build a linear regression model, and your x variables are there and they are related to each other. Suppose there were two variables in that, like weights in pounds and weights in kilograms. As you can see, both are representing the same values but in a different range. As you can see, these two values are having, they both are having high correlation, as both numbers are representing somewhat the same values only, because in pound and in kilogram they both are same only, so they are highly correlated. So what you can do, you can remove one of the column and try to build the model of linear regression, and you can handle this by removing one of the columns. So that is what it is called. If like the other columns were there, like the two columns were there, and suppose you can consider like it was height was there, one variable, and the weight was there, and you can see there are, as the height increases, the weight also increases there. Then there also, there you can see there is high correlation. So if that type of columns are there, then you have to remove one of them and then you try to build. If there is low correlation, then what you can do, you can remove one of the column there as well, and you try to build a linear regression model. That is what written over here. To check the assumption, we can use a correlation matrix or VIF score. If the VIF score is greater than 5, then the variables are highly correlated and the column we need to eliminate. If the columns are highly correlated, then you have to remove that column. Then the next is the error term. Error term should be normally distributed. After building the linear regression line, we can see the residuals or the error terms. There should be normally distributed. If it is normally distributed, then it is meeting your assumption of a linear regression. And how you can check this? If your residuals are heavy, is normally distributed or not by checking these plots, QQ plots and histogram. This was the fifth assumption. Last assumption is no autocorrelation. This is also related to the error terms only. After making the linear regression line, you can see the error terms. If the error terms are showing pattern like this, then it is positive autocorrelation. This type of error terms, if you are able to see after making your linear regression line, so it is not meeting the assumption. So if the residuals are or the error terms are not having some pattern and they are evenly distributed, then you can go with this because it is and because the assumption of this is the residuals should be evenly distributed and they shouldn't follow a pattern like this. If it is not following any pattern and it is randomly, the errors are randomly distributed, then there is no autocorrelation. So you can go with the linear regression model and it can give you some you can get a good result by the linear regression model. How you can check this if the residuals are having some pattern or not? By the Durbin-Watson test. When you will be here it is written, the null hypothesis assumes that there is no autocorrelation. The value of the test lies between 0 to 4 of the value of the test is 2, then there is no autocorrelation. Hypothesis we will be seeing in the next question. When questions related to statistics I will be covering. In that video, uh, I will be completing all the questions, important questions related to statistics. But now we will be just seeing the linear regression assumptions. So here the value of test lies between 0 to 4. Here you can see the values are from 0 to 4. And if the values are nearby 2 or at 2 or nearby 2, then there is no autocorrelation. So it is meeting the assumption. So you can go with the linear regression model. If it is lying over here 0 to uh, year to year or from year to year, I will be drawing and showing you. If the values are from year to year and if the values are year to year, that means they are positive autocorrelated or negative autocorrelated. If they are positive and negative autocorrelated, then you can't go with the linear regression model. You have to try some other model or you have to handle that assumption. And if the values are from year to year, nearby 2 or 2, then it is no autocorrelated. So it you can get good result by linear regression model itself. Next is this much only the assumptions were there. From first we saw the assumption of linearity. Our values should be having a linear relationship with our y. This was our first assumption. Then second was our x should be normal. Second assumption was x and y variable should be normally distributed. Third was homoscedasticity. Our error term shouldn't our error term should be constant. There shouldn't be a variance in there. That was our third assumption. Homoscedasticity. Error term should be constant over the error term should be constant. This was our third, homoscedasticity. Fourth was multicollinearity. If any of the columns are highly correlated or positive correlated or negative correlated, then you have to remove that column and then try to build a linear regression model. This was the fourth one, which was no multicollinearity or independence. Then the fifth was the error term should be normally distributed. If you are plotting your error terms and if they are following normal distribution, then it is meeting the assumption. This was the fifth one, and the last one was no autocorrelation. If the error term you are plotting after building the linear regression model, it shouldn't be follow some of the it shouldn't be follow patterns. If it is evenly distributed, then it is meeting the assumption of linear regression. So this was the last assumption. I hope you understood the concept which I taught you today. And if in the interviews this question is coming, so if you have understood this video, so you can speak and you can answer the questions related to this topic. Or let's see the after our assumptions are, if some of the assumptions are not met, then what? So we will be seeing over here how to deal with the violation of any of the assumption. If the some of the assumption are not met, then what? It is written over here. So I will be explaining you. The violation of the assumption leads to a decrease in the accuracy of the model. Therefore, the predictions are not accurate and error is also high. If some of the assumptions are not met, then your model will be not accurate and the error term will be high, which I told you earlier. That point is written over here. So the error means all the assumptions should be met if you are trying to build a linear regression model on one of the data set, which is of the y is of continuous type, then your all the error means all the assumptions should be met. If it is not meeting, your your accuracy means your predictions will be not accurate and the error term will be high. For example, if the independence assumption is violated, then the relationship between the independent dependent variable cannot be determined precisely. If the variable is having a relationship, like the x variables are dependent on each other, then it can't be able to find out the relationship between the y variable. So that what it is written over here. There are various methods are techniques available to deal with the violation of assumption. Let's discuss some of them below. Violation of normality assumption of a variables or error term. If the x is not following a normal distribution, then what? You can transform that uh, values into a normal distribution by using the transformation function such as log transformation, reciprocal, or Box-Cox transformation. So by using this transformation, you can convert your x independent variables values into a normal distributed form. So by that you can handle that assumption. If the multicollinearity assumption is violated, then what to do? Uh, Doing nothing. If there is no major difference in the accuracy, if the multicollinearity assumption is not met, your it will be not impacting that much. Your prediction will be not affected that much. And removing some of the highly correlated independent variables above in the above topics means before only I told if the some of the highly correlated variables are there, then you can eliminate that columns and try building the model once again. That can give you good results. That is what written over here. Deriving a new feature by linearly combining the independent variables, such as adding them together, perform some mathematical operations. deriving a new feature by linearly combining the independent variable. Here what it is written, making a new features altogether by combining the independent variable, adding together, perform some mathematical operations. Means you have to do some changes by adding them together and performing some mathematical operations on the variable, and if then try to see then also it is multi-coordinated or not. That is what it is written over here. So you can change the variables, independent variables. And the fourth is perform an analysis designed for highly correlated variables. If you are able to see some of the variables are highly correlated, then you can just try a PCA. This is a technique where you can try to remove one of the variable which is highly correlated, and try to build a model, linear regression model, and then you see the accuracy, then you see the predictions are how much it is correct and how much it is not. So these all things you can do when the assumptions are not met. You can try this all these things when the assumptions are not met. So in this video, we went on checking what were the assumptions, and if the assumptions are not met, then what to do. If you have not understood this video, you guys go through this video once again, and then if you are not able to understand, then go back and then understand it. It is easy, but it will be taking some time. So take your time and study properly. So if you have liked this video, please like, share, and subscribe my channel, and meet you in the next video, guys.